You know, when we think about chemistry, we usually picture boring formulas on a blackboard. But what if I told you it can also be a spectacular, colorful magic show? Well, that's exactly what we're going to dive into today. So here's the big question, the central mystery for us to solve. How is it possible for one single element to act like a chemical chameleon, completely changing its look over and over again? The answer is pretty amazing, and it all comes down to how these elements react to their surroundings. Let's see it in action. All right, let's meet our two stars of the show, copper and cobalt. When they're just dissolved in water, you can see copper solution has this gorgeous, brilliant blue color. Cobalt, on the other hand, is this really delicate pink. So these are our starting points, our baseline. Now, let's start mixing things up.
First up, we've got copper. We are about to follow it on a journey through a series of reactions. You're going to want to watch closely as this master of disguise changes its colors right before our very eyes.
Okay, so we're starting with our blue copper solution. Now, watch this. As soon as we add some chloride, bam, the whole thing turns this vibrant yellow. So what's actually happening? Well, those chloride bits are basically kicking out the water molecules that were hanging around the copper ion, and that little switcheroo completely changes how the complex absorbs light, giving us a brand new color. But what if we add hydroxide instead? You get a totally different result. A pale blue solid actually forms and starts to sink to the bottom. We call that a precipitate. It happens because this new compound it doesn't dissolve in water anymore. So this isn't just a color change, it's a physical transformation too. And for the grand finale, if we add ammonia, the solution turns into this incredible, deep royal blue. It's the same idea again, another molecule swap. It just goes to show you that every new ingredient we add creates a totally unique environment around that copper, unlocking yet another color from its amazing palette. All right, that was copper. Pretty cool, right? But now it's time for our second chameleon, cobalt. It starts out pink, but as you're about to see, it has its own very unique bag of tricks. So we start with our pink cobalt solution. Remember what happened when we added chloride to copper? It turned yellow. Well, with cobalt, we get this deep blue solution. It's a fantastic example of how each metal really has its own chemical personality, you know? You give them the same ingredient and they react in their own special way. Next up, adding hydroxide gives us a blue precipitate. It's a solid, just like with copper, but again, a completely different color. And then there's ammonia. This one's kind of surprising. It creates this very subtle straw-colored solution. Once again, every molecule we introduce changes the world around that little cobalt ion, and a new color is born. But hold on, cobalt's not quite done showing off. It has one more amazing trick up its sleeve, and it's something copper just can't do. And here's the real magic. We take that blue solid we just made, and all we do is heat it up. That's it. The heat gives it the energy it needs to drive off those water molecules, and that fundamentally changes its entire chemical structure. And the result? A totally new substance, a solid red precipitate. It just goes to show you that chemistry isn't just about what you add, it's also about the energy you put into the system. Okay, we've seen them perform their solo acts. Now it's time for the main event. Let's put our two chemical chameleons on stage together and really compare their performances side by side. This table just lays it all out so perfectly. Look at this. You add the same thing, chloride, and copper turns yellow while cobalt turns blue. You add ammonia, and copper goes deep blue while cobalt turns into that pale straw color. The patterns are completely different. And this isn't just a cool party trick. This is actually how chemists in a lab can use simple color tests to figure out what unknown metal they're looking at. So really, the biggest thing to take away is this. You can use the same ingredients, but you got a completely different chemical recipe. Why? Because the unique structure of each metal dictates exactly how it's going to react, creating its own distinct visual fingerprint. So what's the bottom line here? Well, we've seen that elements like copper and cobalt are true chemical chameleons. They have their own unique color signatures that they reveal when they react to their environment. And it's so important to remember that these beautiful color changes aren't just for show. They are powerful visual clues that tell us exactly what's happening at the molecular level. Honestly, we've just scratched the surface of the incredible, vibrant world of transition metals. It really makes you wonder, doesn't it? If copper and cobalt can put on a show like this, what other elements out there are just hiding, waiting to reveal their own colorful secrets? Thanks for joining me on this one.